Please like, share and subscribe our channel to learn and enjoy our free online educational videos from class nursery to 10. Please click the bell icon to get all new updated videos.
Lesson 2. Fractions. You have learnt about fractions and their types: proper, improper and mixed. Fractions on the number line, equivalent fractions, simplest or lowest form of a fraction, comparing fractions, and addition, subtraction of fractions. If you cut a whole apple into 4 equal pieces, then each piece is 1/4 of the whole apple. 1 whole of a fraction. You know that when a whole one is divided into equal parts, each part is a fraction. The whole may be a single object or a group of objects. A whole one can be divided into 2 halves or 3/3 or 4 quarters and so on. 1 equal to 2/2. 1 equal to 3/3. 1 equal to 4/4. 1 equal to 5/5, etc. More about fractions. Proper fractions are those whose numerator is less than its denominator. For example, 5/6, 15/23 and 118/205. Improper fractions are those whose numerator is greater than or equal to its denominator. For example, 8/3, 19/7 and 704/704. Mixed fractions are the combination of a whole number and a proper fraction. For example, 2 3/4, 5 1/6 and 26 13/18. To convert an improper fraction into a mixed fraction, divide the numerator by the denominator of the fraction. The quotient is the whole number part, whereas the remainder forms the numerator part of the mixed fraction. For example, 8/3 is equal to 2 2/3. Equivalent fractions represent the same part of a whole. To obtain the equivalent fractions of a given number, multiply or divide its numerator and denominator by the same non-zero number. For example, 4 multiplied by 2 upon 5 multiplied by 2 is equal to 8/10. 4 multiplied by 3 upon 5 multiplied by 3 is equal to 12/15. 4 multiplied by 4 upon 5 multiplied by 4 is equal to 16/20. Are all equivalent fractions of 4/5. Like fractions are those fractions which have the same denominator. For example, 5/9, 6/9, 8/9 and 15/9. Unlike fractions are those fractions which have different denominators. For example, 3/4, 7/8, 5/12 and 3/11. To convert unlike fractions into like fractions, first find the LCM of the denominators of the given fractions and represent each of the given fraction into an equivalent fraction, having the denominator equal to the LCM of the denominators. Example: convert each of the given fractions 2/3, 4/15, 5/6 into like fractions. LCM of 3, 15 and 6 is equal to 3 multiplied by 5 multiplied by 2 is equal to 30. 2/3 is equal to 2/3 multiplied by 10/10 is equal to 20/30. 4/15 is equal to 4/15 multiplied by 2/2 is equal to 8/30. 5/6 is equal to 5/6 multiplied by 5/5 is equal to 25/30. Thus, the required like fractions are 20/30, 8/30 and 25/30. Addition and subtraction of fractions. A rectangular sheet of paper is 13 1/4 cm long and 11 2/5 cm wide. Find its perimeter. Perimeter of rectangle equal to 2 L plus B is equal to 2 13 1/4 plus 11 2/5 centimeter is equal to 2 53 upon 4 plus 57 upon 5 centimeter is equal to 2. 53 multiplied by 5 plus 57 multiplied by 4 upon 20 centimeter is equal to 2. 265 plus 228 upon 20 centimeter is equal to 2 multiplied by 493 upon 20 centimeter is equal to 493 upon 10 centimeter is equal to 49 3 upon 10 centimeter. Hence, perimeter of rectangle is equal to 49 3 upon 10 centimeter. A wire of 12 4 upon 11 meter length is taken to fence around a rectangular garden. Of the given wire, only 10 1 upon 7 meter is used. What length of the wire remains unused? Length of wire not used is equal to 12 4 upon 11 minus 10 1 upon 7 meter is equal to 136 upon 11 minus 71 upon 7 meter is equal to 136 multiplied by 7 minus 71 multiplied by 11 upon 77 meter is equal to 952 minus 781 upon 77 meter is equal to 171 upon 77 meter is equal to 17 upon 77 meter. Hence, 17 upon 77 meter of the wire remains unused. Multiplication of fractions. Multiplication by a whole number. Observe the adjoining rectangles. The shaded strip represents 1 upon 3 area of each rectangle. The two shaded strips taken together represent 2 multiplied by 1 upon 3 equal to 1 upon 3 plus 1 upon 3 equal to 1 plus 1 upon 3 equal to 2 upon 3. This can be represented as 2 multiplied by 1 upon 3 is equal to 2 upon 3 is equal to 2 multiplied by 1 upon 3. Multiplication of a fraction by a fraction. Let us find 1 upon 2 of 2 upon 3, that is 1 upon 2 multiplied by 2 upon 3. In the adjoining figure, the shaded part represents 2 upon 3 of the rectangle area. Now, 1 upon 2 of 2 upon 3, which is 1 upon 3, is represented by the double shaded region as shown in the adjoining figure. Hence, 1 upon 2 of 2 upon 3 is equal to 1 upon 2 multiplied by 2 upon 3 is equal to 1 multiplied by 2 upon 2 multiplied by 3 is equal to 1 upon 3. Value of the products of fractions. Comparisons of fractions and their product. Methods of comparison. Consider the product of two proper fractions, a upon b and c upon d. A. If AD is greater than BC, then A upon B is greater than C upon D. B. If AD is equal to BC, then A upon B is equal to C upon D. C. If AD is less than BC, then A upon B is less than C upon D. Division of fractions. Division of a whole number by a fraction. Let us find 1 divided by 1 upon 2. How many halves are there in 1? You know that there are 2. Therefore, 1 divided by 1 upon 2 is equal to 2. Also, 1 multiplied by 2 upon 1 is equal to 1 multiplied by 2 upon 1 is equal to 2 upon 1 is equal to 2. Therefore, 1 divided by 1 upon 2 is equal to 1 multiplied by 2 upon 1. Division of a fraction by a natural number. Based on our earlier discussion, to divide a fraction by a natural number, we multiply the given fraction by the reciprocal of the natural number. 5 upon 6 divided by 5 is equal to 5 upon 6 multiplied by 1 upon 5 is equal to 1 upon 6. Similarly, 8 upon 3 divided by 4 is equal to 8 upon 3 multiplied by 1 upon 4 is equal to 8 multiplied by 1 upon 3 multiplied by 4 is equal to 2 upon 3. Division of a fraction by another fraction. In order to divide a fraction by another fraction, we multiply the fraction by the reciprocal of the divisor. 1 upon 3 divided by 5 upon 6 is equal to 1 upon 3 multiplied by 6 upon 5 is equal to 1 upon 3 multiplied by 6 upon 5 is equal to 2 upon 5. In general, A upon B divided by C upon D is equal to A upon B multiplied by D upon C, where C upon D is not equal to 0. Similarly, 1 upon 2 divided by 1 upon 3 is equal to 5 upon 2 divided by 1 upon 3 is equal to 5 upon 2 multiplied by 3 upon 1 is equal to 5 multiplied by 3 upon 2 multiplied by 1 is equal to 15 upon 2.